Welcome, curious minds. Today, we're going on the ultimate journey back in time, to the very beginning of everything we know. Forget about ancient history, we're going for cosmic history. We're talking about the Big Bang. You've heard the name, but you might have the wrong picture in your head. The Big Bang wasn't a giant explosion in space like a firecracker going off. The truth is far more bizarre. Before the Big Bang, there was no space to explode into, and there was no time either. It's a bit of a head-scratcher, I know. So what was it? Instead, think of the entire universe, all the stars, galaxies and planets crammed into a single, unimaginably tiny and incredibly hot point. We call this a singularity, a point smaller than an atom, yet it contained all the matter and energy that would ever exist. Everything. About 13.8 billion years ago, this tiny point began to expand at an incredible rate. This wasn't an explosion space, but the rapid expansion space itself. As the fabric of the universe stretched, it also began to cool down. Imagine drawing dots on a balloon and then blowing it up. The dots themselves aren't moving across the balloon's surface, but the space between them is growing. This makes them all appear to move apart from one another. This very principle is at play on a cosmic scale, explaining why distant galaxies are receding from us today. In the very first moments, the universe was an incredibly dense and hot plasma, too energetic for anything to form. It was a chaotic soup of fundamental particles like quarks and electrons. But as it expanded and cooled, things started to stick together. Quarks combined to form protons and neutrons. Eventually, after about 380,000 years, the universe cooled enough for electrons to be captured by these nuclei, creating the first stable atoms. These were primarily hydrogen and helium, the building blocks for all the stars and galaxies to come. So how can we be so sure about an event that happened billions of years ago? The answer lies in the cosmic clues left behind. We have two monumental pieces of evidence. First, the expansion of the universe itself. We see that distant galaxies are moving away from us because their light is red-shifted. This means the light waves are stretched out, shifting towards the red end of the spectrum, much like the sound of a siren changes as it moves away. Crucially, the farther away a galaxy is, the faster it's receding. This observation fits perfectly with the idea of an expanding universe that started from a single point. The second, and perhaps most powerful piece of evidence, is the cosmic microwave background, or CMB. Think of it as the afterglow of creation, the leftover heat from the Big Bang. This faint microwave radiation fills the entire universe, a persistent echo of its fiery birth. Discovered by accident, this CMB is essentially the universe's first baby picture, capturing a snapshot of the cosmos when it was just 380,000 years old. The Big Bang is not just the start of our universe's story, it's the beginning of a cosmic journey of discovery. Every time we look at the stars, we're looking at a universe still expanding, still cooling, and still telling us the tale of its very first moment. What a story, huh? Thank you for joining us on this cosmic adventure. Until next time, keep looking up and stay curious about the universe.